As you can see, we have a jumbo-sized egg sitting on the narrow mouth of this 64-ounce glass box. Use a napkin to start a fire inside this bottle. Okay. If you watch closely, you will see the bottle filling with smoke. There you have it. We created a partial vacuum inside the bottle, and the pressure was no longer equal. So the air pressure above became greater. So we have a net force. And Newton's second law states that whenever you have a net force, the result will be the object will accelerate. And we saw the egg accelerate to the bottom of the jar. Now, this simple experiment demonstrates all three laws of Newton's laws of motion. First one, which states that an object will remain at rest unless some external force compels it to change that state. The egg was sitting here, not moving. We had to bring an external force to force it into the jar. The third law says action and reaction are equal in magnitude and opposite in direction. That's why the pressure inside the bottle originally canceled out the pressure above the bottle. So the egg did not move. As soon as we destabilize that equilibrium of forces, acceleration occurs. And that is the second law of Newton. Ladies and gentlemen, this is a demonstration of an example of the law of inertia. Newton's first law of motion is sometimes called the law of inertia because objects tend to resist any changes in a state of motion. In other words, if an object is at rest, it wants to continue at rest. It did not budge at all. That's the law of inertia. Remove the paper, and the flask remains where it is. We have a variation to this demonstration of the law of inertia also. I will get a card. We have this card that's sitting on this flask, and I'm going to put a coin at rest on the card. And I'm going to send the card in motion. According to the laws of inertia, the coin is going to tend to refuse or resist the tendency to move with the card. Okay? Are we ready? We're going to send the card flying. And if everything goes well, the coin should fall right into the flask. Okay? That's the law of inertia. Good morning, class. Today, our challenge for food of thought is how can I pour water into this cup, all right, and hold the cup at a horizontal position without a drop of that water leaving the cup. So we can pull by the pull of gravity. And we're going to swirl the cup around our head, around my head, to see if indeed we can hold this cup in a horizontal position without a single drop leaving the cup. Okay, so here we go. Here we go. Believe me, the water is still in the cup. Here we go. All right, for those of you who are wondering, the water was in the cup all that time, and not a single drop left the cup. To prove it, I'm going to pour it back into the larger cup. That's our demonstration today.